we are going to practice and look at how we get rid of annoying things like fractions and decimals. Because who likes fractions? Nobody and liars, right? Nobody and liars like fractions. So let's get rid of those suckers. How do we do it? We clear the parentheses first if there are any, and then multiply both sides of the equation by the LCD, which is the least common denominator. LCD means least common denominator of all terms in the equation. So if I look at number 1, we've got the values of 3, 6, 12, 18, 24, 36. Because 9 times 6 is, oh, well, we don't want to go that high, but that's 54. But 3 can go into it. 36 is 3 times 12. I mean, these are just multiples that 3, 6, and 9 can go into. But well, really, 9 doesn't go into 24, and 9 does go into 36, right? That's 9. Yeah, that is 9 times 6. Where's my head? That's 9 times 4. Hello. 9 times 4 is 36. We don't really want that one. But in any case, what I see when I look at 1 is 3, 6, and 9. I say, oh, okay, 3 can go into 6. Awesome. 3 can go into 9. Awesome. But can 6 go into 9? No. Not awesome. So that means of our values, our least common denominator is not 3, and it's not 6, because 9 cannot go into 6 or 3. It's also not 12, because 9 doesn't go into 12. And it's not 24, because 9 doesn't go into 24. And it could be 36, and it could be 18. Because 9 goes into 36, that's 9 times 4. 3 goes into 36, that's 3 times 12. 6 goes into 36, that's 6 times 6. But the golden one is 18, because that is the least common denominator. Because 6 times 2 is 18, 3 times 6 is 18, 6 times 3 is 18, 9 times 2 is 18. So the ideal number is 18. But if you went with 36, not a big deal, no one cares. You can use 36. It just means you have to reduce one step more in the end, but again, who cares? As long as you get rid of the fractions appropriately, it doesn't matter. It all comes out in the wash. But the ideal number, yes, is 18. So what we want to do is multiply everything through by 18. So that I have 18 times 1 over 6x equals 18 times 2 over 3 plus 18x over 9. The reason why I left the numerators as is, like times 1 times 2 times x, is because we chose 18 specifically so that it would reduce that with the denominator. And if I leave it unmultiplied, it's a better visual. So 18 divided by 6 is 3, times 1 is 3, so this is 3x, equals 18 divided by 3 is 6, times 2 is 12. Now, plus 18 divided by 9 is 2 times x is 2x. And now we have a much prettier version of the equation. So if I move the 2 to the left, we end up with x equaling 12. And just to combine the last thing we talked about, would this linear equation be contradiction, conditional, or an identity? Yeah, this is a conditional. So moving on to 2, what's the ideal value for the least common denominator for 2? Well, not 7. That is not a denominator because technically here this is 7 over 1. Not 2, because 8 does not go into 2. Not 4, because 8 does not go into 8. Sorry, 8 doesn't go into 4. Forgot what I was saying. It could be 12. Or no, excuse me. It could not be 12 because 8 doesn't divide into 12 nicely. So again, we're down to 8 and 16. 4, 8, and 2 all go into 8 and 16. The ideal number here is 8 because it is the least common number. But again, you can use 16 and it's not the end of the world. I don't care. You'll just have to do reducing at the end. But 8 is the ideal number. So what we're going to do is multiply everything through by 8 to clear the fractions. So again, I have 8 times 3 over 4 plus 8 times 7 over 8 equals 8 times 7 over 1 minus 8 times 1 over 2x. Now reducing all of these things respectively, we get 8 over 4 reduces to 2, 8 over 8 is 1, 8 times 7 over 1, 1's just, there as a placeholder. 8 divided by 2 is 4. So I've got 2 times 3, which is 6, plus 1 times 7, which is now 7, equals 8 times 7, which is 56, minus 4 times 1, which is 4, times x is 4x. Oops, I forgot my x term from my first. That's 6x. So adding 4x to the left, we get 10x equals, subtracting 7 from the 56, we get what, 49? So 10x equals 49. What's the last step? Divide by 10. So x equals 49 over 10. And there you go. Hopefully that wasn't too shabby. I'm going to leave 3 and 4 for you to practice. Come get the answers from me if you need them.